Mr. Ashok Muthuswamy, AVP and Plant Head Silica Tata Chemicals Limited. He is going to talk on the topic of robust planning and implementation of turnarounds. So Mr. Ashok has 25 years of extensive experience in manufacturing, operations, Lean Six Sigma, supply chain, quality and project management. And he had a lot of improvements which he has brought in the silica plant of Tata Chemicals. And prior to this role, he was the director of Global Continuous Improvement Program in TCL, where he created an efficient global enterprise through optimizing operations. So he has done his MBA from University of Phoenix, USA, University of Texas, USA, and engineering from University of Madras. So Ashok is an active contributor to CII and IIM Kolkata and University of Phoenix. So welcome, Mr. Ashok.
Hi all, good morning. So last couple of days, you would have heard a lot about all the details of, all the technical aspects of plant turnarounds and shutdown. I'm just going to take a little bit back seat, and my presentation is not going to be so much about technical aspects, but it's going to be about how you can manage a turnaround in a robust way. How do you plan for turnaround? How do you ensure that you shrunk the time? And also, how do you manage uncertainties? So it's going to be more of a management systems and philosophies behind turnaround. Okay. So just before we get into the presentation, there is a quick overview about Tata Chemicals. So as you can see, Tata Chemicals has two verticals. One is basic chemistry. So we are the world's third largest producer of soda ash and also world's sixth largest producer of bicarb. And we also produce Tata Salt. So that's our basic chemistry portfolio. Besides that, we also make marine chemicals, chlorine, bromine, and a few other chemicals. And then we are now also getting into the specialty chemicals. As you can see, we are investing a lot in agrosciences, Nutra solutions, and material sciences and energy sciences. So that's a quick nutshell about Tata Chemicals. Tata Chemicals has undergone a lot of change. We put our focus on these areas. Earlier, we also had a fertilizer division, but we had to divest that because we want to focus on these selective areas. And we are a global company. We have plants in US, UK, Kenya, India, South Africa, and operations in South Africa. So pretty much a global company with 5,000 people. And roughly our sales this year is going to be around 12,000 crores. And we have so far we have achieved 124 patents. We also have 220 plus scientists in our company. We have an innovation center in Pune. And several of them, I think a big number of them are PhDs. So that's a quick intro about Tata Chemicals. So it's like, how do you use science to create a differentiated value proposition to the customers? That's where we are. Just a little bit, I think I touched upon it in my previous slide. So we are the top 10% of business and consumer brands. Tata Salt is our product, and it is India's #1 food brand. And then, as I mentioned earlier, we are the third largest soda ash manufacturer, sixth largest bicarb manufacturer, and we are also into prebiotic products. We have world-class R&D for nano and biotechnology. And besides that, we are also very much into CSR, going above and beyond the call of duty. So we have a center of excellence for coastal and marine conservation, and we also have a center for sustainable agriculture and farm excellence. So that in a nutshell is what is Tata Chemicals. Okay, let me grab a water. So just give me 1 second. Thank you. Okay, so as I was referring earlier, we are now getting into some of the specialty chemicals, and In that, what we did is we acquired silica factory in Kadalur, which is near Chennai in Tamil Nadu. And right now I am the plant head of this facility. We took over a plant which was not in a great shape, and put a lot of efforts to bring it up to class. And okay, so now having given you a very quick overview about Tata Chemicals, so let me also now get into this subject. So turnarounds, there are few characteristics of a turnaround. One is the entire operation is shut for a while, and that brings you a significant revenue and profit loss, right? And huge expenses, obviously. And then you are also exposed to a lot of unfamiliar elements than your normal operations. In your normal operations, you know exactly what to do, and so on and so forth. Whereas here, you get into all these unknown entities, whether it's using some special tools, equipment, expertise, labor. You get a lot of folks from outside. So all these can create some kind of confusion and chaos. And also safety will also be a significant aspect that needs to be very properly managed during turnarounds because of heavy lifting, working in heights, and obviously bunch of new personnel. So in some cases the number of people will actually double, especially during turnaround, because you will be getting so many folks from outside. So these are all some of the challenges. So it's really imperative to really scope out your turnaround, plan it, and more importantly, execute it in a flawless manner, right? So, and my presentation is going to touch on those management aspects of turnarounds. Okay, so before I get into that, I just want to put this concept, cross-domain thinking. So, why cross-domain thinking, right? So, some of the problems have already been solved somewhere else, right? See, for example, how many of you have seen lizards? Lizard can crawl in the wall, they can even cling into the ceilings, go on a very smooth glass surface. The reason is lizards have some tentacles, around thousands of tentacles in their feet, which have a spatula tipped shape, and they create a molecular adhesion with the surface they are in contact. So some companies are working on creating adhesives and glues which are simulating lizards' adhesive techniques. And then do not reinvent the wheel, so just figure out how you can leverage concepts which are perfected elsewhere. And then you can also have a very interesting synergy of cross-domain knowledge if you could assemble it all in a given place. And once I go into my presentation, this will make a lot of sense. I know I'm just out of nowhere, I'm just putting this, but I will connect the dots. So what we did for turnaround is exactly that. Apply cross-domain knowledge. So one is, obviously planning, streamlining activities, and managing uncertainties. And I will go into the details. So planning, very obvious. Then streamlining activities is where we have taken a lot of concepts from lean manufacturing. Some of you, actually lean manufacturing is a lot more popular in the automotive sector relative to chemical industry. So there is a lot of cross-domain knowledge you can go and you can imbibe from automotive sector and put it into the chemical area. So we have taken the single minute exchange of dyes, SMED. Some of you might have heard about SMED. So we have taken that concept, which is very, very automotive centric, changing the dye kind of concept, and we have taken that and used that body of knowledge in turnaround. Similarly, managing uncertainties. Some of you might have heard about Goldratt. He has written a book called The Goal. Anyway, who is familiar with Eli Goldratt? He's an Israeli nuclear physicist. Sorry? Yeah, theory of constraints. So, if you think about it, theory of constraints is very typically applied to production and supply chain. But how could you also apply theory of constraints into turnaround? So, these are some of the unique combinations which we did, and which it has given us some extremely significant results. In fact, some of the Tata companies are world-class benchmarks for turnaround compared to the industry peers. Okay, so like I alluded earlier, our approach to manage turnaround is obviously planning. How do you do a robust planning? How do you ensure you have resources and other activities in place? And then how do you use some of the lean manufacturing and SMED concepts to streamline activities? And then how do you manage uncertainties? As I mentioned, theory of constraints. And there is another special body of knowledge called critical chain project management, which is not same as there is another, it's not same as CPM. It's a slightly a different concept. This was also put forth by Eli Goldratt, CCPM. It's not the same as critical path method. It's somewhat different. So we have, as I mentioned, integrated all these various different concepts into a cohesive whole to manage turnarounds in Tata Chemicals actually. So now let me discuss about the planning. Should I pass? Sorry? Oh, from the next room. Okay, all right. Okay, so planning for turnarounds. So these are the 5 areas that you need to be aware of. Nothing fancy, but nevertheless there are precisely around like 32 checklists. If nothing else, this will give you 32 unique items which you can put as a checklist and make sure that you're covering all these things. So one is obviously first is it starts with scoping, budgeting, and approval, followed by skills planning, because in turnaround the skills that you have will certainly be very different from what is needed while executing a turnaround. Similarly, spares planning, obviously workforce planning, you need to get a lot of expertise, specialists coming in, and services planning, so you need to hire some firms, right? So these are various aspects of planning, and I will quickly touch over each one of them, but I will not go too much deep in the interest of time. So here is scoping, budgeting, and approval. So what kind of what type of maintenance you are interested, whether it's on-stream maintenance, proactive maintenance, O&M, or capital replacement. So based on that, you do assessment of estimated resources, and then you do a costing, budgeting, you compare with the previous budget, again review by management, and finally you come up with a precise financial calculation about what should be, how much you should spend, what should be the scope, and so on, right? And next very important aspect is skills planning. So what kind of skills that is needed, and how do you need to develop those skills? Like do you need to develop a training calendar? Whether it should be how advanced you have to plan that? Should you plan a year ahead so that you are training your people, so that not everyone is going to the training at the same time? And then you impart the training, review the training effectiveness, and then you just make sure that your folks are ready for such executing the jobs. And obviously spares planning, another extremely important aspects. So estimating the spares, checking availability, and initiating a procurement plan, because these are several of them will have a very long lead time, and how early you can plan this procurement becomes extremely important because of the lead time, which will typically be, in several cases, it may take months for certain special items to get in-house. And then how do you stage material where required and all that stuff. And then workforce planning. So finding out the skills and number of people you need, and working with the service providers, and putting a contract, and then also onboarding people. So another extremely important aspect. And services planning. So what kind of, identifying what kind of services you need, documenting and scheduling the services, initiating the service contracts, and also syncing up with other areas like, whether spares or resources. So these are, typically like 5 areas of planning, as I mentioned earlier. How do you get all these things in place? This goes a very long way. So we have a detailed checklist. So as I mentioned, there are around like 33 or 34 boxes, and for each of these boxes, we have a very detailed checklist, and make sure that all these activities are carried out in a very robust way. Okay, so now that I have done with the planning, let me jump into the streamlining activities. This is where I'm going to touch upon the lean manufacturing concept of single minute exchange of dies. So if you see in turnarounds, what is a turnaround, right? So here is your last batch of production, and then there is your next batch of production, and the time in between is how much you spend for the turnaround, and it can be split into several buckets. At least these are 4 most prominent buckets. You're preparing for turnaround, actual work, adjustments, trial runs, and that's how you define the turnaround time. Now the idea is how you shrink this between point A and B. Should it be this big, or can you shrink that? So that's what we will be discussing in the next few slides. So let me just go a little bit one step back and explain this concept. Some of you might have known about single minute exchange of dies, but for those who are not familiar, this was a concept which was put forth by Toyota in 1940s when Toyota was a very small company. They didn't have too many press machines, stamping presses to make those car body parts. Whereas unlike Ford or General Motors, they can just crank out, they can have dedicated punching presses for each one of the parts, whereas Toyota only had one machine or very limited machines, and they have to do multiple parts in a same machine. So what they did is they came up with this concept called single minute exchange of die, meaning which how soon I can swap the die from one part to another so that I can operate my plant with just very limited set of equipment. And but the same concept can also be applied for turnarounds also. So there are 3 specific areas in SMED. One is separating internal and external setup. Other is converting internal setup to external setup. Third is streamlining all aspects of setup. Let me just quickly touch upon each one of them. So here is one second. So in the first step, you segregate between what is internal setup and external setup. Internal setup is an activity which you need to perform when the plant is down during the turnaround. Whereas, for example, somehow lining of the refractories or cleaning pipelines, ducts, and so on. Whereas external setup is an activity that could be performed while the plant is running, whether it's staging your tools and hardware, scaffolding, loading programs, all these things. So having a very clear understanding of all the things that goes into a turnaround, and finding out whether it is internal to the turnaround or external. And external, you can do it even while the plant is running. You don't need to shut the plant, right? It will look very simple, but actually there is a lot of, it needs a lot of effort to understand. And next piece is converting some of the internal setup into external setup. Something you will be assuming that you have to shut down the equipment to do that. But you can figure out, can you move some internal to external? For example, in this case, you have to start the equipment and you have to heat a die. So that takes some time. So can you preheat the die? This is one example, right? So finding out ways to convert some of these internal setup to external setup will also go a long way in shrinking your plant turnaround time. And next piece is streamlining all aspects, whether it's internal or external, doing parallel operations, right? In project management, those who are in project management, the concept called, there is a start to start. So how parallelly you can schedule activity and you can execute them shrinks your time for delivering the project, or using few other techniques like eliminating the adjustment, functional clamps, mechanization. I'll just quickly touch over on each one of them. So in other words, whether it's internal or external, how you can use some of the lean manufacturing concepts into shrinking that, that's what this particular item is about. See, for example, how, instead of having a very free spot, if you could have some kind of a stopper, so you can just snap it, right? Just an example, but I just put this to trigger your thought on how you can eliminate all the adjustments. So everything should be snappable, right? And to some extent, this has to be done not during the turnaround, but while designing your equipment, designing your plant, you have to design so that it is designed for turnaround. We have heard about concepts called design for manufacturability, design for assembly and all. So you can also, when you are putting up a chemical plant, you can also incorporate some of the turnaround aspects during designing of the equipment. And obviously organizing, having everything in place for everything while executing the turnaround. And you can see this guy is going mad when everything is all over, whereas if you put everything there, how you can organize and all that. So, but summarizing all these different things which I mentioned, so if you see, if you are not clear about what is internal and external, you will consume a whole lot of time. If you very clearly know what is internal and external pieces you will be doing while the equipment is running. And then as I mentioned earlier, some of the internal could be moved to external, so you will be further shrinking the time. Then once you streamline everything, you will only need this much time to do the turnover. And if you compare with that one, you will be saving a whole lot of time, right? Sure. Okay, so so that said, I would also like to touch upon my third concept of accommodating uncertainties using CCPM. So if you see any project, you will, let us say a project, has like 6 steps. Normally what we do, we will be padding each activity with a buffer, right? So nobody likes to give a time exactly. If it's going to take 2 days, we are used to give like 4 days or padding up with whatever. So critical chain project management deals with this particular thing. So instead of padding each activity with a buffer, what you do, you schedule each activity with only the time it takes, and then have a common pool of buffer for all the other activities. For all the uncertainties. So if my project or if my task A is completed on time, I move to task B. I don't wait for the total time. But if I am taking some unwantedly excessive time on any particular task, I go and consume that from the common pool of buffer. So if you put the buffer like this as a common pool, most of the time you see like 50% reduction in the buffer time. And it also gives you a lot more comfort because you have one common pool of buffer, so you have a pooled buffer instead of an individual buffer. So, so here is a turnaround which has been scheduled in that way. So as you can see, there are all these various tasks, but we have this common buffer. If any one of these tasks is taking more time, we will be consuming from this common buffer. So this technique is, as I said, it's called critical chain project management, CCPM. It's a whole body of knowledge. I suggest if you are interested in this, go ahead and Google, and it's a very interesting body of knowledge. And then other aspect is if you have one constrained resource or one constrained equipment, it could be a person, it could be a machine, it could be a software, whatever. So how do you stagger your need for that resource so that not all of them are competing for that at the same time? So this is another concept which I want to put forth. So anyway, so getting the long story short, so here is your project time, and here is how much buffer you are consuming, and then if this is the critical chain project management, CCPM. So as I can see, all my tasks are completed, and so I know the health of my project. Using this is called a fever chart. I know the health of my project. If a project is in red, I know that I need to shrink the time. If the project is in green, I know I don't need to do anything, right? And then this is called multi-project fever chart. So all my, if I have like 15, 20 activities in my turnaround, I can see the health of each of these activities in this chart. So activity A, B, C, D, E, F, I can see which activity is on time, which activity is in the red zone. And then what I can also do is I can convert some of the resources in the green area to some of the laggards in the red area, so that I can bring that also to hopefully an early closure. So as I mean, the takeaway is three aspects which we used in Tata Chemicals. One is thorough planning, and other is activity streamlining using lean manufacturing and SMED. Third is managing uncertainties using critical chain project management, and not padding each activity with individual buffer, but consolidating them into a common pool and staggering the resources without overloading them. And this gives us ability to do successful plant turnarounds. And as I mentioned earlier, cross-domain approach provides a lot of synergies. So with that, ladies and gentlemen, thank you so much.
So everything what Ashok has spoken is clear?
Yeah, wonderful. So either I have done a great job or it's the other way around.
That theory of constraint, the little bit explain who the book author mentioned also. Theory of constraint.
Yeah.
There is some LD Goldin that book.
Yeah.
Please elaborate a little on that. Is the book available or what?
Your book is available. You have 1 month course, 1 year course, everything.
Okay.
So now Goldrat is no more. So his son is moving it forward.
Okay.
Okay. So it is. It will be very interesting for you to do that course.
Okay. Okay. Thank you.
Hello. Just a minute.
Okay.
Who can be part of this planning team?
Sorry, who can be part of the
this
planning?
team?
You need to have obviously a very cross-functional team, starting from the site head and the key technical and other resources. And obviously it has to be a cross-functional team, and make sure that you have representation from entire organization so that you are not missing anything.
From top line to bottom line or only top line?
Sorry?
From bottom line also?
From bottom line?
Yeah.
I'm not sure. So you are saying from all levels of
Yeah,
employee?
all
Yeah, I
levels.
would suggest, yeah, see, most of the time the people who are doing the job know more about that particular job than most of us, right? So it's in your interest to go and tap that knowledge.
Okay. Thank you, Mr. Ashok,
Thank you.
for that enlightening presentation. Yeah, you have a question. Okay.
Whatever you shown in this presentation, have you used this practically in your any organization for this?
Yeah,
shutdown?
in Tata Chemicals, in fact, we had.
Any case study you have or something?
This is an amalgamation of, see, case study, we cannot exactly share a case study because of proprietary thing. But what you see here is something that it's not, we did what we are preaching here. So it is just an amalgamation of what we did in Tata
Which
Chemicals.
plant you have used it at?
See,
Tata?
we had one very large urea plant. We had one urea plant, which is not with us right now. In that plant, actually, we used this.
You're talking about the Babrala? This
Yes, yes. Yeah, the Babrala plant, which I mentioned, is a urea plant. It's a Pakka chemical plant. Sorry? Sorry, I'm not following. Resin plant. See, this is a generic technique. It's really domain agnostic. You can apply to any field. Just need to have some little bit of creativity when you are applying in any given field. But of course, it can be used, to my knowledge. Yeah.
Okay, so I think with that question, we'll close it. He is available for you during networking lunch and networking tea. Thank you, Mr. Ashok. Yeah. So the next presenter we have Mr. Deepan Kumar.